We're going to finish up chapter 3 review. Sorry I couldn't get it into one, but I didn't want to rush either because, like I said, a lot of material in this chapter. All right, so continuing with problems with stoichiometry. Okay, here's one we need the number of grams reacted with grams. So it's grams to grams is 3 steps, 3 conversions. Okay, so balanced equation. Okay, it says hydrogen gas reacted with chlorine gas produces hydrogen chloride. Okay, and again, I know that hydrogen and chlorine are diatomic. Remember, there's 7 of those that when they're by themselves, there's always 2. That's important when you're writing out equations. Okay, so I got hydrogen, chlorine, and it's balanced. So I got a balanced equation. This would be synthesis reaction. Okay. All right, so it says I got 450 grams of hydrogen gas. That's what I start with. First thing I got to do, I got to get rid of grams of hydrogen. So I put 1 mole, and since it's H2, 1 hydrogen is 1, but there's 2 of them, so it's 2 grams. So that takes care of grams. Then I do my mole ratio. I put moles of hydrogen on the bottom and moles of what I'm trying to find. It says here the number of grams of HCl, so I put that on top. Then I go to my balance equation, 2, 1. Okay, so now I got rid of moles of H2, change it to moles of HCl. And now I got to change that because it wants grams, so 1 mole. And if you take 1 hydrogen and 1 chlorine, and put them together, you get 36.5. Again, this is the formula mass. That's what you could get from your app on your phone if you have it. So to solve this times this times this divided by 2, and that's where you get. So when I have 450 grams of hydrogen gas, I can produce 16,425 grams of HCl. So I can produce quite a bit. Okay, one more. Now this one, I want moles, so I have one less step. Okay, remember to be careful to read your question. I mean, read them carefully because don't always go gram to gram. Sometimes it's less than that. Okay, so it says how many moles of aluminum hydroxide is needed to react with sulfuric acid to produce 256.4 grams of aluminum sulfate. And one thing I learned from this problem, you guys, if you ever have to type out formulas in chemistry, pick the smaller ones, because I kept doing aluminum sulfate. You know, I got a subscript, 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 subscript. It was crazy. So from now on, I'm picking the smaller ones like H2O. You know what I'm saying? Anyway, enough of my problems, right? Okay, so I start with what I know. 256.4 aluminum sulfate. Okay, then I put 342 over 1 mole. That's what it weighs. Okay, that's 2 aluminum, 3 sulfur, and 12 oxygen added together. So that's where that number came from. All I've done so far is gotten rid of grams of aluminum sulfate and change it to moles. All right, and then the question says, how many moles of aluminum hydroxide? Okay, so now I need my balanced equation. And again, if you don't have one of these, you can't do stoichiometry. So I put 1 mole of Al2SO4 because that's what I got here. And I'm looking for aluminum hydroxide, so I put that on top and I got a 2 there. So if I was looking for water, I put 1 mole of Al2SO4 and I put 6 moles of water on top. Whatever the coefficient is in front, that's what you use. And it says how many moles? Well, that's where I'm at, so I get to quit. So I take 256.4 times 2 divided by 342, and I get 1.5 moles. So when I start with 256.4 grams of aluminum sulfate, I end up with 1.5 moles of aluminum hydroxide. Or that's how many moles of aluminum hydroxide I need to produce that much aluminum sulfate. Okay, so when you're doing stoichiometry, what you're doing is you can look at how much reactant you need to produce a certain product. You can look at how much product you produce from a certain amount of reactant. It looks at the relationships between reactants and products. Okay, here's another one. How many, when 2.9 moles of mercury 2 oxide decomposes? Okay, so I started with moles on this one. First I wrote a balance equation, nice simple one. And the reason why I started with moles on this one is don't change this to grams, you guys. If it starts in moles, that's good. That means you don't have to change it to grams. That's one less step for you. Okay, so I change it to moles. 1 mole of, all I did here is use my mole ratio from my balance equation. So I put my moles of HGO on the bottom and my moles of what I'm trying to find, oxygen, on top. Okay, this is a 1 and this is a 2. Okay, so if you start with moles, your first conversion is just the mole ratio. Don't change it to grams because then you got to change it back to moles. You're actually adding 2 steps if you do that. Excuse me. And then I take 1 mole of oxygen, and remember oxygen's O2, so that would be 32 grams, not 16, because there's 2 oxygen. So 2.19 times 32 divided by 2, and you get your answer, okay? Again, when you're doing these, you can have moles to grams, you can have grams to moles, you can have grams to grams, or you can have moles to moles, okay? So you just have to read your question carefully, okay? All right, now limited reactant is one more step, okay? You're going to find, you're going to do a mass to mass or mole to mole or whatever, and then when you're done, you're going to look at your answer, and with limited reactant, you basically compare one reactant to the other to figure out which one you run out of, okay? So if I start with 45 grams of manganese, this would be 4, I guess, manganese dioxide, no, that'd be manganese 4 oxide, and 69 grams of HCl, which one's my limited reactant? Okay, you pick one. You don't use, like if I start with this, I don't use this number in my equation. I wait when I'm all done to look at that number. So don't use both the numbers they give you. Okay, so I start with my 45 grams of MnO2. I get 1 mole is 87 grams. That's what it weighs. Then I look at my balanced equation. Okay, 1 mole here to 4 moles here. Okay, and then 1 mole of hydrogen chloride is 36.5. Okay, so I take 45 times 4 times 36.5 and I divide by 87. This is what I get. Okay, so when I have 45 grams of MnO2, manganese dioxide, I need 75.5 grams of HCl. That's what I need. I look up here and it says I have 69. I don't have enough. Okay, so HCl is my limited reactant. If you would have started with 69 grams of HCl, you would have found a bigger number than 45, and then you would say, oh, it's still my limited reactant. So it doesn't matter which one you choose, you're going to get the same limited reactant. And make sure when you do these products or problems, you tell me which one's a limited reactant. Some people do all the work and then they don't tell me which one's a limited reactant. The limited reactant limits how much product you produce. Okay, it's the one you run out of first. All right. And then we also did percent yield. Okay, here I have an equation. We're going to break down potassium chlorate into potassium chloride and oxygen. All right. So decomposition. We're starting with 75 grams of potassium chloride, and when we're all done, we do a reaction. We actually decompose this. We find out we have 14 grams of oxygen. Well, did we do a very good job? So percent yield is checking to see if you did a very good job. So you start with the reactant, in this case 75 grams of KClO3. Okay, I'm going to change it from grams to moles. Okay, so this is the mass of KClO3, 122.5. I'm sorry I didn't write KClO3. It's just hard to get it all in on one line. Anyway, so I've gone from grams to moles. Now I use my mole ratio, what I'm trying to get rid of on the bottom, and what I'm trying to find on top. And then I look, and there's a 2 there, and there's a 3 there. So those are where they come from. And now my last step is I got to change moles of oxygen into grams. So 1 mole of oxygen is 32 grams. Now remember, this is the only time you use the balanced equation. These are always 1 mole. If you're going from grams to moles or moles to grams, you just use 1 mole. This is the only time you use the balanced equation. So 75 times 3 times 32 divided by 122.5 divided by 2. Okay, so I get 29.4. This is what they call my theoretical yield. In a perfect world, if I did everything right and I started with 75 grams of potassium chlorate, I should get 29.4 grams of oxygen. That's the max I can get. Okay, that's called theoretical yield. So now you look up here and it says, well, when you did it, you got 14 grams. So this is my actual yield. This is what I really got when I did it. So I take what I got, 14, divided by what I should have got, 29.4. Okay, so this is the actual, this is theoretical. This is the max you'll ever get. And if your theoretical yield is over 100, you guys, you divide it wrong because you can't have over 100. Okay. Anyway, I get 0.4762 or 47.62%. So I didn't even get half of my yield. So I probably need to look at this and see what I'm doing wrong. Fix something. I'm losing oxygen somewhere. So I've got to, redo my procedure or do something to fix it because I'm really losing quite a bit. Okay? So that's how you do percent yield. Okay, the rest of this slideshow, there are 4 different slides, and you guys can go through it. I'll put it on without me talking. I think I might have already done that. But anyway, I have some slides, and what I want you to do is I want you to do the problem. All I have is the answer, okay? So I have, here's a couple where you're doing gram to gram, that kind of stuff. I have, here's a percent yield. And again, I just have the answer. So you guys got to try to do the problem. Make sure you balance your equations. Here's some conversions, grams to moles, moles to grams. And again, I just wrote the answer. So it's up to you. You don't have to do them, but it's for you to practice. Okay. And then I think there's an empirical formula and a molecular formula. And I think that's it. Yeah. So those are there for your practice if you want to do them. The answer is there, but you have to do the procedure. And if you have troubles with those, just let me know. Give me send me an email and I will go through them with you if you need to be, if you really get confused on them. But again, you don't have to do them. They're there for your, if you need extra help. Okay. So that's the end of the review for chapter 3. Good luck with your test.